So maybe just to get everyone situated, think of InOrbit as being the single pane of glass, one way to manage everything. So in this case, we're using a made-up customer called Brickmart. They're a retailer with retail stores and distribution centers around the world. They have over 100 robots. We're going to focus on one location, which is where I'm at right now in the robot space. Now, when you have a fleet that's distributed, that's around the world, you need to know what's going on with your robots. So InOrbit will give you a overall view of your whole fleet. If you're an operations person, typically you care about the robots that are not happy. So you can say, okay, just show me the robots that need attention, show me why they need attention. You can also drill down to individual incidents or to a particular location. That's exactly what I'm going to do. I'm going to focus on this one site, the robot space, which is here in Northern California and Silicon Valley. That's where I'm calling from today. And to prove to you that this is a live demo, I can show you, we have integrations with cameras. So this is me, hello, I'm waving, you can see me in the camera. So what we're gonna do is we're gonna create in this space a situation with multiple robots trying to carry out tasks in a shared space. And we heard from Felipe, for example, about forklifts, which if these were animals, I would say they're the natural enemy in the habitat of robots, manually driven forklifts. So being able to track elements like what Brian was saying is going to become critical. But for now, we're going to focus on these robots. And one of the things that we're able to do is put multiple robots basically on the same map. Now, of course, each robot will build its version of the map, very much in line with what Brian was discussing. So this is what this Mir 100, this is how it sees the world with its unique sensor package. If I switch to an Auto 100, it's obviously the same space, but it will see it a little differently. We have our little picking robot here, and it has its own view. But these maps are not the most human-friendly, so we like to use an annotated map that's a little bit easier to understand. You can see we're getting, a lot of data. We can see the LiDAR return camera view. So rather than go into the details of this, let's take a step back and, I mentioned this is a retail store, so let's go shopping. We're going to buy a couple of our hugely popular mascots, Orbito, about 3 of those. You go back. Oh, no hoodies. Okay, some water bottles, maybe. 2 water bottles, let's say. So, of course, this is just a standard e-commerce website hosted by Square. I have this very special coupon. And now when I check out, a lot of things will happen very, very quickly. So when I place that order goes to a warehouse management system. And of course, there's a number of WMS systems out there. We're just using one for our purposes. So that order is now being picked up by InOrbit. And what we're going to see, if I'm not too fast, we'll miss it, is we see the robot moving towards that location. Let me give you a better view here. Before our helpful warehouse associate fulfills the order. So you can see there's a pick-to-light system as well here. Is using InOrbit on his phone to indicate that the order is complete. And you can see the robot is waiting for an item, and now it's moving on towards its destination. So We just saw a classic case of picking, where it's a collaborative effort between an associate and the robot. Now, you may have noticed that we were out of hoodies. So our system also dispatched a restocking robot. Now, here's the restocker next to me trying to go through the door. We also control the door. But check this out. We had both robots trying to go through the door at once. That would have been a disaster, right? So InOrbit can basically do traffic management across brands. So in this case, it was an intersection or a door. So it paused one of the robots while the other robot continued. You can see the robot is waiting for the single occupancy zone to be ready. Once that area is clear, this robot continues towards the back where the items will be picked. So I think what's interesting here is we had integrations with IoT devices like a door. We had integrations with cameras, integrations between different robots. And now when the robot arrives at its restocking location, you can see the pick to light here. That shelf is glowing orange because it needs some hoodies. And now Chris will fulfill that and goes to the tablet that's mounted on the robot and basically says, great, we've completed that order. So again, and the robots continue through their tasks. How are these tasks defined? So let's talk about missions. So missions is a way to define the robot behavior. And of course, we can integrate with its native fleet manager, but also we can define missions that are generic. And the benefit of that is now you can see the performance of all the robots across all of these different missions. And oh, oops, there's an alert here. It looks like the waypoint is blocked. So one of the things that you need to do is do problem resolution. So let's see what's going on. So you can see the robot is trying to get there. Let's see. Okay, looks like there's something blocking the way. Let me just pick this camera and yeah, it looks like somebody left a pallet there. I really wish we had that ultra wideband tags from SIG already installed, because then we'd be able to know that something is there. But in the meantime, let me try and fix that. So in this case, I'm going to connect to our Auto 100 and tell it to go return the cart. So just to be clear, I'm not controlling the robot. I'm basically nudging the robot to do the right thing. So in this case, this is using Auto's native fleet manager and navigation. And it's going to go towards let me see, here's a better view. It's going to go pick up that cart, that pallet loaded with boxes. And I'm going to wait until basically the coast is clear and it's safe for the Mir 100, our restocker robot, to continue. So as soon as this moves out of the way, I think it's thinking how to get out of there. There we go. So as soon as this is out of the way, I can do, and I'm going to do it here from the UI so you can actually see it, but I'm actually getting alerts on my phone via Slack. So I could resolve the problem directly from Slack. But here you'll be able to see it. I'm going to clear the error that this robot has. And then there. So let me retry that mission. And there we go. So the robot got to its destination. So I think maybe just as a quick recap, we were able to see some missions in real life. We were able to see things as they were happening, but maybe I want to go back in time to a few days ago and then look at a mission that was carried out by a robot. So because InOrbit is recording everything that's going on, we can now do, go back to a previous mission from days ago. We can see all the data about the robot, all the incidents, everything is correlated, of course. And then I love looking at the heat map, which shows me where the robot is spending its time. And one thing I can see here is there's this extra stop here. I don't know, like this is the shelf, this is the door, all of this makes sense. But I may want to go back and investigate why the robot was spending time here. Because that might be an inefficiency, and then that allows me to continuously improve the operations. So to recap, we saw content from all of these, interactions with all of these different robots all working together.
Yeah, that was great, Florian. I obviously think it's amazing. It's really cool to see, these different robots from different vendors working together. I think that people who are just getting into this sort of space, there's a lot of concern about how to approach, RobOps and orchestration of various robots. When you get into, a production setting, you start small, but very quickly, once you start seeing success, our experience with all of our customers has really been, you start seeing success and immediately you're like, well, if my robots are working well, picking, why wouldn't I add a floor cleaning robot? Of course, that just makes sense. So can you talk maybe a bit about InOrbit's approach to interoperability and how we manage that?
Yeah, of course. So there's all of these different use cases that could be automated. We saw even today, we saw the amazing work from InStock, but once that bin comes out, where does it go? There may be an AMR waiting for it. And then you need to keep that warehouse clean, right? So you can use a car share robot for that. And we're not going to have one company build everything, right? Car share specializes in cleaning equipment. They're going to make this amazing cleaning robot, not necessarily an ASRS system, and conversely. So I think it becomes really critical to be able to not just have them operating in the same space, but also have consistent analytics across the board. And the way we do that is we're sort of like the Google Translate of robotics, right? So we're able to connect to each robot through its native mechanisms, whether it's an API or if it's a ROS robot, will run on the ROS robot. If it has a fleet manager, we'll connect to the fleet manager. So there's lots of different ways, but then you have this consistency of view. So this allows the ecosystem to develop more, where each company is focusing on what they do best. But as an end user, you can get the best from everyone and put it together for your needs.
Yeah, absolutely. Absolutely. And I think really that, when you were going through the mission analytics in particular, and by the way, everyone, this is brand new. We have a press release going out next week about that. So you're getting a little preview of it, but, that it's so powerful to be able to see, your multiple robots in the same analytics dashboard, compare them over time. It's just a really powerful orchestration tool.
Yeah, I think we're pretty excited, and I think there's many. Felipe was mentioning about VDA 50/50. We actually support VDA 50/50. We support mass robotics. We support open RMF. So these are emerging standards that are out there, but they tell you how to talk to the robot. They don't tell you what to do with the data that you get from the robot. So I think even with a VDA situation where InOrbit is a master controller in VDA speak, you can still mix and match. So let's say not all your robots are compatible. You can bring a robot, even a legacy robot, and integrate it with your new VDA-enabled robot. So that idea that you can have that technical interoperability that's emerging, and we're contributing to standards, we're making open source contributions. But regardless of all of that, which some of standards move fairly slowly, we can you can already do a lot of this today.